My name is Frode Brandt. I'm the principal software engineer here at TechSoft. And I've been working with CIE and the Ceetron line of products for about 16 years now. We mainly focus on creating SDKs for reading, processing, and visualizing any kind of CIE data formats on both desktop and cloud. We are a technology provider for many of the big players in the industry like ANSYS, Autodesk, DNV, SimScale, TransferLore, HBK, to name a few. In this session, I will demonstrate how easy it is to get started with the CDC. We will load and visualize a CIE file and then do some simple post-processing using our C++ interface. And hopefully we have time for some questions at the end. I'm just going to share my screen. So we'll do some actual real coding. Let's see, share. Can you see my screen now?
Yep, looks good, thanks.
Okay, good. So let's see what we have. So we're going to work on the latest CDC release. We will try to open a CIE file. And I made a batch file here just to set up Qt and the Visual Studio development environment. So let's just start that one. Then create a working directory. It's called CDC. Let's extract the release, which will give us these files. We will have a look at all the examples, a Qt example. Let's look at the Qt minimal, which is a great starting point to using CDC with Qt. So we have some source code files and a Qt project file. Let's create a Visual Studio project out of that profile. Like that. And let's open the Visual Studio. That will give us the following files. So here you see the files that we saw in that directory. In addition, we have some interrupt source code, interrupt some glue between CDC and Qt. Let's just see if this starts out of the box. Yeah, so this is the main function, the entry point. Let's see what happens. The first thing that happens is that it complains about the license. So I have created an evaluation license that we can use. You see, it still works without the license. It just complains a lot. In this view, we have three boxes and a sphere. This is pure geometry. It has nothing to do with CIE. So we're going to change that. But first, let's fix the license. So this evaluation license should be valid out this month. Build and run to just verify that it works. Okay, so that message is gone. That's good. So we are going to use a component called the Unstructured Grid component, which is sort of the CIE domain knowledge component that we have. So I'm just going to include that component here. In order to use it, we need to initialize the components. See, we use a lot of namespaces, so C for Ceetron, UG for Unstructured Grid. And then we initialize it the same way as we do with any other components. So here we have the geometry component containing the boxes and the sphere and the visualization components. In order to use this out of the box, we need to add the Unstructured Grid library. Let's see, inputs. So this is release. Let's do the debug as well. The debug library has a D in addition. Like that. Okay, so just verifying that this works. I'm just going to start it again. Still working. That's good. Okay, so let's go and see. Let's look at the actual scene and the code. But first, let's add some header files that I know that we will use. So this is the scene that you just saw. So what happens here is that there is a viewer. The viewer is sort of a glue layer between Qt and CDC. The viewer has one view. And when this function starts, application starts, it starts by removing all the existing models if you have it. Then it creates one model for all the three boxes. It creates a new model for the sphere. They could be in the same model. In this case, it's just an example. So so they use two different models here. But we're not going to use the geometry models. We're just going to remove them from that code. At the end, it grabs the bounding box of the view and sets up the camera. So let's see if we can start using the Unstructured Model. So let's create a CIE model. We use a lot of smart pointers called PutRef. First, we create a model. Then we need to add that model to the view. So if this is a smart pointer, we need to get the actual raw pointer. Oops. Which is done like this. So we always send the raw pointer into the function calls. Just going to check if this compiles and runs. It does. So now there are no geometry here. Just that blank scene with a background color. So far, so good. So let's try to open a file. So there was a VTFX file, a CIE file in the root folder. So let's see if we can find that. Called Puppet file. It's a VTFX file. We can load any kind of CIE file formats, more or less. Dastra, Nokia2, or yeah, most formats. This example will do a VTFX file. In order to open a file, you need to create a data source. Again, a smart pointer. VTFX. I don't have to spell something here. Yeah, missing E, okay. Data source VTFX to contain the database. And a data source needs an ID, a unique ID. So just pick one. And then you can say source open on that file. Let's add a safeguard in case it won't open. And then you need to add the source to the model. Again, a smart pointer like that. But you still won't see anything because a CIE file contains a lot of different states and you need to pick one that you want to show. So let's select a state. The first thing you do is that you will get all the available states in the database. So you ask the source about its directory, which is sort of like query components or structure, and that you can ask for all the different state info. So now we have them all. So I'll safeguard around this one as well. So if there are no states, you just bail out. So now we know for a fact that we have at least one state. So let's get the first available state. or actually the ID of it, like this. And then you inform the model, or actually the model specification, that you want to use this state. Like that. And whenever you've done setting up your scene, your database, you should tell the model that you are sort of done doing so. Update visualization. See if this compiles and runs. So there are a few lines of code, you're able to open a CAE file. Right now, this just looks like any other CAD model. So let's see if we can see some CAE stuff. Let's try to apply a scalar result value to it. So again, let's get all the available scalar results. Source, directory, scalar result infos. Running a bit short on time, so we will just use it. I know for a fact that this model actually has at least one scalar result. So let's inform the model spec that we want to see the settings spec. See that scalar result as fringes. Let's see. Let's just grab it. Actually, let's get the first one. Like that. And apply it. Well, run. So now we have plotted the first available scalar, which is a velocity magnitude. Okay, so let's see if we can do something else as well. Let's try to create a cutting plane. Again, smart pointer. And then we need to configure it. Let's create a point in the origo. And we can create a normal, let's say, along the x-axis. I think it should look okay. And then we need to enable it. It still won't show because you need to add it to the model. Again, smart pointer. Then update visualization. Compiles. And now you can see that the model has been cut in half with a gray default color. A bit boring, so let's see if we can do something about that. We can not the contour, we will do a scalar. We can map that exact same scalar result that we have mapped on the full model to the cutting plane itself. See, it looks much better. Let's see if you can do something else in cutting plane. We have something called crinkle cuts, which is quite nice. Just enable it. So instead of having a flat cutting plane, it actually sort of calculates the intersection between or on all the elements and remove everything above. So that's crinkle cuts. And with a slider, you can interactively slide this cutting plane up and down, so it looks very nice. Yeah, I think we have time for a little bit more, so let's do an ISO volume. Again, start pointer, define the class we're going to use, an ISO of surface, do a volume. Then we need to configure it. Like coding at its best, always some typos. So we apply the scalar that we have used for the code. We will set a minimum and a maximum threshold. Let's do from 3 to 6. While at it, let's plot this exact same scalar on the ISO volume geometry as well. And as always, you need to add this to the model. But in order to see this, you need to sort of hide the real geometry of the model, because an ISO volume will be inside. I'm just copy pasting in a little loop here that loops over all the parts and change the draw style to outline, since we're running a bit short on time. Remove the cutting plane because that makes no sense. It compiles and it runs. Now you can see the model itself is rendered with outline, and you can see the ISO volume. And we said from 3, which is roughly here, that's the bottom here, and 6 should be red. You can see there are some elements not being rendered here, which are further up on the scale. I think that's all I have time to present, but it shows that it's quite easy to load a file and to do some simple post-processing in just a few lines of code.
That's fantastic. Thank you so much, Frode. And this is really part of a much larger portfolio that reads a variety of data, meshes it, analyzes it. We're just going over some of the display technology, and you have this both for desktop and cloud. Is that right?
Yeah, absolutely. We have something called the Ceetron cloud components, which basically does the same thing in the cloud.
Yeah.
It uses the same sort of backend. The CIE domain knowledge is the same code in the backend of the cloud.